All right, so this was a little bit longer lesson, so I guess you guys got a break to start, so that's good. All right, so now if you notice on this section, we've gone from arithmetic sequence, arithmetic growth and decay, arithmetic series. We went geometric sequence, geometric growth and decay, now geometric series. That's pretty much the chapter so far. Arithmetic and geometric, and they're going to slide in. Next lesson is going to be infinite series. Okay, that's ones that don't end. Okay. All right, so then geometric series, if you remember your what series is just adding up the pattern. Okay, so here it's a geometric because 2, 4, 8, 16, it's timesing by 2. Okay, so we understand that that is geometric. Okay, I'll kind of explain what they're talking about here, but I think it's better to go with what the formula is. What they're talking about here is they went ahead and did the series, and the series times r, so that kind of gets you the next one in line. And then they subtracted line 1 from line 2, so they did RSN minus SN, AR minus A, so these pieces subtracted. And then they took the GCF, this one has an SN, so they pulled an SN out. This one has an A, so they pulled an A out. And they divided this R minus 1 over, okay, to get the formula here. Okay, these formulas are the same except for T1 and A are just written differently. Remember the story I told you about the arithmetic series about how Gauss did that pattern? Similar idea here, just not a story to go with it. Okay. All right, so this formula you use when you're given A, R, and N, or S of N. You need 3 of these to use it. So you need A, R, N, or S of N. You need 3 of those in order to use that formula. Okay, when we get done today, I'm going to give you guys a separate piece with the formulas on it, so you don't have to keep flipping back and forth in your book. Save you a little bit of time today. Okay, the one down here, the only difference is this is when you don't know the term number. So when we don't know T sub n, okay, when we don't know the number of terms, we know T sub n, we use this. So it's like, it'd be an example if I had 3, 6, 12, and then it went 256 or something. I don't know what term number that is. But I do know that's T sub n. I just don't know what n is. So you take that 256 and you put it right here, okay, for the T sub n. Now, the only difference in these two, again, is they have A and they have T1, same thing. So again, it's not 2 formulas, it's just written 2 ways. I usually just use the A one. Why does it say that R can't be 1? Why does it say that R can't be 1? Not nothing on the bottom. Right, it'd be non-permissible, right? 1, you can't divide by 0. We talked about that already this year, so that's why. Another reason why, let's just think about it in general. If R is 1, why does that not make sense? What is R? Right, it's common ratio. 1 times that number, you'd have the same number forever. So it makes no sense. So that's why R can't be 1. Okay, all right, so let's go ahead and look at this little brief example. I'm going to do it in this small space here because you need to see this piece here. Okay, so what it wants us to do, it wants us to take this and show how we can turn it into this. Okay, so by doing that here, we're going to go A times R to the n minus 1 over R minus 1. We're going to distribute the A. We're going to get AR to the n minus A all over R minus 1. Then what we're going to do is we're going to pull an R out of here because I'm trying to get a T sub n, and T sub n is the same as this right here, AR to the n minus 1. So if I pull an R out, if I'm taking R out, that means I'm pulling off one of the exponents, so it's going to make it an n minus 1. That's what we're looking for. I'm writing it too big here, sorry. So I pulled an R out, so instead of making an n now, it's n to the minus 1. Okay, and then we have this as an A. And so what we're going to do now is understand that this relationship here, I can put it, this is equals T sub n. So if I put a T sub n in, R T sub n minus A over R minus 1, you'll see that that's right there. Okay, any questions? Okay. Let's go ahead and go to the next page here. We got about 4 examples in a row here of just practicing using the formula. So the applied stuff. Okay, so determine the sum of the first 15 terms of the sequence -5, 10, -20. So what I want to do is figure out, what do I have? Do I have A? Do I have R? Do I have N? Okay. Do I have A? Yeah, A is -5. Do I have R? Yeah, R is at what? Times -2? And then N tells me 15. Okay? So now we have 3 of the 4. I want to use the first formula. So if we turn back here, or I don't have to turn back, you probably do, I guess. I want to use this one. Bless you. Okay, that's the one I want to use. Because you see, everything to the right, I have that variable. So I'm going to go S of, we're doing 15, equals -5 times -2 to the 15th minus 1 all over -2 minus 1 is a -3. It's right there. It's all plugged in. At this point, there's no need to go ahead and do this all in your head and stuff. Just put that in your calculator, and it'll punch out a pretty big number. In this case, it's going to punch out -54,615. Okay, now let's understand what we just found. We just found if I continue this pattern to the 15th term and add them all up, it equals that. And it's kind of interesting if you looked at the pattern. 15, let me ask you a question here. What is my odd term numbers? What kind of numbers are those? Odd term numbers. Like up there, T1 and T3 are what type of number? Negative, right? And then we asked for T15, so it was negative. See the battle? They're going back and forth. It'd be like if we did T14, we'd have a bigger positive number. It'd keep going back and forth. Okay, because when you're adding them, that last number is going to be kind of really big, so it's going to kind of take over what's behind it. So just kind of think about that in terms of this is negative because we ended on an odd term number. If you tried an even, I bet you it's positive. But anyway, just an observation. Okay, example 3. Now this one, they give me the pattern, but I don't know what term number that is. So this is where we want to use formula 2. Okay, so if you look at it, we have A is 4, R we still do know is -3. We don't know N, but we know what T sub N is. So we want to use this one. Want to use this one. So in this case, my R is -3. My T sub N is 8,748. And minus my A, which is 4, all over -3 minus 1 to -4. Okay, again, you punch that in your calculator, you get -6560. What if they want us to figure out what term number that was? Well, we could go back to our general form, and we could work backwards. We could put -656. So remember your general form is T sub N equals AR to the N minus 1, right? That's our general form for geometric sequences and series. So we could plug this in right here. We have an A, we have an R. We would have to just figure out what N was by kind of guess and check there, but just something to think about. Okay, let's do 4. All right. The sum of a certain number of terms in the series. Okay. So it tells you what the sum is. The sum of a certain number of terms in this series of -2, 8, -32 is -104, 858. What is the last term would make this series add up to that? So it's saying is your S sub n is -104, 858. And we still know A, and we still know R. R is -4. So what we don't know is we don't know N, or T sub N, I guess, is what they want, because they want to know what term value is the last one. So we don't want to know N, we want to know T sub N. So if we want to know T sub N, then that should take us to, whenever you see the T sub N, we should be thinking this one. Okay, so now I'm going to plug everything in that I have. I'll put this here and here, put that there, and I'm going to put this right there. So the only thing that's going to be blank is the T sub N. Okay, so -104, 858 equals -4 T sub N minus a -2, so +2, all over -4 minus 1, -5. And then from this point, we're into our algebra. We got to solve for T sub N. So I got to multiply -5 to both sides to get rid of the -5. Okay, and then that gets you 524, 290. -4 Tn plus 2. I'm going to -2 divide by -4 now. I'm just solving for x. This right here is like my x. So T sub N ends up being -131,072. So what that means is the last number in the sequence that would add up to 104 would be that. Okay, let me ask you this. That's kind of weird. -131 is bigger than the 104 that's the sum. Why? Why is it -131,000? It's like what it's saying is if this thing kept going, -131,072 would be the last term, and that would give you this as a sum. Why is that last term smaller than the actual sum? Exactly, because there's positives in front of it. Okay, that's right? So the positives in front of it is what changes that. Okay, good. All right, let's see here. 5. Move it up here so I have a little more room. All right, in geometric sequence, the fifth term is 1024, and the common ratio is 8. Okay, find the sum of the first 7 terms. So I want to find S7. Okay, the fifth term, so T5 equals 1024. The ratio is 4. So I don't have A. A is the thing I need. Okay, because I have N. N they want over here. They want, so we know R is 4. This is what they want. N is 7. We don't know A. That's what I need to figure out. So we're going to go back to your general form. Okay, so I'm going to do 1024, because I'm doing T sub N equals A, which we don't know. So Rn minus 1. R is 4. N minus 1 in this case would be 5 minus 1, so to the 4th. So 1024, 4 to the 4th, I think we did earlier, was 256. A, divide 256. You get your A is 4. So now we have our A is 4, we're good to go. Now we have 3 pieces of the information we need. So now we go back and use the formula we've been using. So S to the N okay. So I want S of 7, so I want 4 times 4 to the 7th minus 1 over 4 minus 1 is 3. That's what I'm putting into my calculator. And that kicks out 21,844. Okay, 21,844. Pretty good picture. Okay. We'll keep going. Don't do it, Nick. All right, 6. All right, so the sum of the terms of the series, 5, 15, 45, up to 16,400. 16,400. Determine the number of terms in the series. So you want to figure out what term number this is. Try to figure out what T sub n is. Solve the equation with a common base. So what it wants me to do first is let's identify what we have. We have A is 5. You can see that your R is times by 3. Okay. N we don't know, but we do know that S sub n is 16,400. That's what it tells me. So the sum of this series is 16,400. So we got to work backwards. So we're going to go back to this formula again. I'll write it one more time. We're going to the A times R to the N minus 1 over R minus 1. So see, we have everything except for the N. So we're going to plug that in. 16,400 equals 5 times 3 to the N minus 1 all over 3 minus 1 all over 2. And so we're just going to solve, okay, we're just going to solve for the N. When you get to the end, you're going to have to kind of guess and check a little bit. Okay, so I'm going to times by 2 first. Gives me 32,800. Divide by 5. Dividing by 5 gives me 6,560. Add 1. So now we need to figure out when does 3 to what power is 6561. Okay, I try 8, and just keep working up until you hit it. Okay, so somebody help me out there and tell me where we get there. Oh, wait, never mind, I gave you the answer. I think it is 8. Okay, so it ends up being 8. So 3 to the 8th equals 6561. So that means n equals 8. So that means it's the 8th term. Okay.
The only way to do it is just kind of guess.
Yeah, kind of guess and check. And then you can also do it like I'm going to show you here on your graphing calculator. Okay, so here's the way you can use your calculator to do it. I'm going to pick it up from right here without the 2's being multiplied. What I'm going to do is you're going to put in your Y1, and go ahead and try this. Y1, I want you to put 16,400 in. Y2, I want you to put in 5. Put in this in your calculator. 5 halves, and then times 3 to the n minus 1, like that, 2 parentheses. Okay, and here's the window I'm going to want you to change to.
Do you go 3 to the power of x minus 1?
Yeah, 3 to the power of the x, and the minus 1's not in the exponent. Yeah, I put it all in brackets.
3 to the power of x minus 1 is in one bracket?
Right, 3 to the power x, and then the minus 1 is in one bracket, yes. What's that? Yeah, your window is going to be this right here. I already got it for you. So your window is going to be, so the first number is your min, second number is your max, the third number is your scale. So 0, 10, 2 for X, your window. Okay, your Y, you're going to want this. 0, 20,000, and then your scale 5,000. That's what you want for your window. You should get a nice big curve with a line going through it. And when you go ahead and hit that intersect feature, you're going to get 8. Okay, go ahead and try that real quick. I'll give you a second. Right, you got 8, 16 to 400, right? The 16 to 400 you ignore, 8's the answer, because 16 to 400 is the sum. Okay, anybody have trouble with that? We good? Okay, all right, so 7 is actually the one from your summative, not exact same, but very similar. Okay, a lot of you guys did the 20 different bounces or whatever. Here's how we can do it. So the golf ball is dropped at the top of a building 100 meters above the paved road. In each bounce, the ball reaches a vertical height is 3/4 the previous vertical height. Okay, determine the vertical height to the nearest tenth after the 7th bounce. Okay, so what we got to figure out here is, one, understand, here's your building. Okay, remember that's a 100-meter drop right there. But that does not count for your T1. So your T1 is not 100, right? The first step you got to do is figure out what your A is. Okay, your A is going to be right here. That's your T1, because that's after the first bounce. Okay, so with that, my T1 is going to be 100 times 0.75, which is your A. So my A is 75. Okay, so my A is 75, my R is 0.75, or you can put 3/4, doesn't matter. My N is 7. Okay, now by doing that, by making this my A, I make this right here my first bounce. So that I'm not mixed up with this being a bounce. I've shifted it over a little bit. Okay, so now what I'm going to do is I'm going to plug into my general form. My general form, I want T of 7 because I want the 7th bounce. Okay, T of 7 is going to be 75 times 0.75 to the 6th. And that would be 13.3 meters. So the height on the 7th bounce will be 13.3 meters. Okay, I'll let you guys get that down because the next part's going to be a little bit harder. Okay, so real quick, I'm just going to erase everything but the building here. Okay, so reading question 2, let's see if we can think about it out loud. The total vertical distance traveled by the ball when it contacts the floor the 7th time. So that means if I kind of drew this, that's 1, right? So that's T1, T2, T3, T4, T5, T6. All right, so T7. Okay, so we have 1, 2, 3, 4, 5, 6 distances. Okay, so the reason I put that is kind of important is we don't have 7 because it says when it hits the 7th time, so we don't want it after the 7th bounce. So when I'm trying to figure out this total distance, so the total distance we're talking about all of this. That's all vertical travel distance, right? So what stuff do I have to add in, and what stuff do I have to count for? What's that? Well, yeah, you have to think all of it, right? But how can I get that as a series? Because if I do the series of this pattern, what is that going to add? If I do the series, because the series is getting us the heights, right? What's that? It's only going to give us the up or down. It's going to give us one side. So, right, so I want 2 S sub n. I want the series times 2, because it's going to travel that same height twice, the up and the down, right? What else do I need to add to figure that out? There's one piece on here that's kind of its own chunk. So 100 meters. This is not part of the pattern. It's not part of the pattern. So I need to go 2 S sub n plus 100. And the S sub n is 6, not 7. Okay? So I'm going to figure out, all I do is figure out what S sub 6 is, times it by 2, then add 100 to it. So S sub 6, I'm going to go to my formula. We do have everything. We know A is 75. We know R is 3/4 or 0.75, and we know N is 6. Okay, so in that I'm going to have for S sub 6, the formula is going to give me 75 times 3/4 to the 6th minus 1, all over 3/4 minus 1. This right here, change to green, this gives me, I'll put that in my calculator, 246.6. I'm going to take that and put it right here. So I want 2 times 246.6 plus 100, and that gives me 593.2 meters. So it travels 593.2 meters. All right. We have 2 more examples left. It's kind of a long day. And we got to do part C, yep. Okay. Everybody good with that? All right. So part C. Okay, how many times does the ball need to bounce to travel 675 in vertical distance? So we want to use that same formula we had. We want 100 plus 2 S of n needs to equal 675. And we're trying to figure out how many bounces. And so what we're going to do is that we need to plug in what S of n's formula is, and we're going to have something missing. The thing that's missing is the n, because that's the number of bounces. So I'm going to go ahead and minus the 100 now. Okay, which gives me 2 S of n equals 575. Whoops, not 78. Divide 2. So S of n equals, I think that was 287.5. Okay, so now what we're going to do is plug in the formula S of n and solve for R. So doing that, it'll look like this. It'll be 75 times 3/4 to the n minus 1 all over 3/4 minus 1 equals 287.5. So 3/4 minus 1 is negative 1/4. So I'm going to times negative 1/4 over here. That's the first step. When you do that, I'm doing different in the book here. 287.5. Yeah. N. Okay, that gives me negative 71. So timesing the negative 1, because that's negative 1/4 here. Time that to both sides, it gives me negative 71.875. Then I'm going to divide by 75. That gives me 3/4 to the n minus 1 equals negative 0.958. I'm going to add 1. That gives me 3/4 to the n equals 0.041. Okay, and then we're going to kind of guess and check. Again, you can use your calculator too, the intersect feature, but ends up being, I believe, to save us a little time here, I started with 10 and ended up being 11. So 3/4 to the 11th equals 0.04. So n equals 11. So the 11th bounce, it will travel 675. On the 11th bounce, it will travel 675. All right. A couple more here. Okay. Consider the geometric series defined by S sub n times 5 to 3n minus 1. Find the first 4 terms of the geometric series defined by that. So we want to find the first 4, so we want S sub 1, S sub 2, S sub 3, S sub 4. So we're just plugging those in. 10. 40. 130. 400. Okay. So, but we want to find the first 4 terms. So we found the first 4 sums. We want to find the first 4 terms. Well, remember, T1 equals S1. So term 1 is 10. And remember, we can always figure out, remember we did that the other day on our proof? 40 minus 10 is 30. That's going to give us our T2. So remember, S2 minus S1 equals T2. Okay, we just kind of keep doing that. 130 minus 40 is 90. And 400 minus 130 is 270. Okay. It says find T sub 9 without using the formula. So what I want you to do is, we got to know T sub 9 equals S sub 9 minus S sub 8. So we can plug in S sub 9. I can do 5 times 3 to the 9th minus 1 minus 5 times 3 to the 8th minus 1. When I do that, it kicks out 65, 610. The numbers these kick out if you care, 98, 410 minus 32,800. Okay, and then that gives you that formula here on the bottom. T sub n is equal to S sub n minus S sub n minus 1. We already did that one. All right, last one. Long day. All right, so let's see here. A little more of an applied one here. Okay, scientists plate E. coli bacteria on a petri dish. At the end of the first hour, 30 bacteria cells are present. The number of new bacteria cells produced each hour forms a geometric sequence. If the total of 40,950 bacteria cells are present at the end of 6 hours, use technology to determine how many new bacteria cells are produced in the 6th hour. Okay, so let's take down from here. We understand that the first hour, it's 30. Okay, now is T6 40,950? No, not T anything. The total number? So it would be S6. The sum, right? Because that means the total including the terms before it. Okay, so right now, all I'm doing right now, I'm just writing down my information. That's all you can do. Okay. All right. So we can work backwards because we don't know R right now. We know A and we know N. So what I'm going to do is I'm going to use this formula here. A to the Rn minus 1 over R minus 1. I'm going to plug everything in, but I don't know R. So we're going to have 40,950 equals 30 times R to the 6th, because it's S of 6, minus 1 all over R minus 1. Okay, this is where it gets kind of complicated, because I have two R's now. So this is where we're going to cheat. Okay, we're going to cheat. I'm going to tell you use your calculator again. So whenever you get to a point where you think it's too hard, think about calculator. This is your Y1. This is your Y2. Okay, I would put it into my Y1 just like it is. Let's see, Y2, I would put it in like, I put it like this, 30 over R minus 1 parentheses. R, and these are R's or X's, right? I'd put it like that in your calculator. Okay, and then your window that's suggested, your X, 0, 10, 2. Your Y, 0, 50,000, 5,000 for your scale. And use the intersect feature. Okay, so I'm going to get that, let me know. Because we're trying, remember, our goal is we're trying to figure out what T6 is. They want to know how much is made in the 6th hour. So in order to get T6, I need to figure out what the R is. Okay, any luck yet? It's close. The answer is 4. So we'll just run with 4. You should have got 4. Okay, so R is 4. Now that R is 4, just to find T6, we just go back to our general A, R, N minus 1. Okay, so A, R, so we want T of 6. So my A is 30. My R is 4. So it means it's quadrupling every hour. Okay, and then my N minus 1 is 5. So I put that in right there. So T6 is going to be 30,720. So the 6th hour, that's how much is produced. 30,720. Okay, and that is all for lesson 7. Okay.